Thanks for giving us the opportunity to talk a little bit about the digitization of our Smithsonian bee collection, and also to talk about some of the challenges related to that. So basically, we're going to talk about what makes digitizing entomological collections complicated. We're going to give you an overview of the 2019-2020 mass digitization of our bumblebees and our carpenter bees, cover a little bit of lessons learned, and then wrap up with some conclusions. Of course, entomological collections are kind of complicated because they're not uniform in storage type with lots of different things, pen, alcohol, as well as slide mounted. The majority of entomological collections are stored dry and pinned with the labels pinned directly onto the specimen, meaning to digitize both, you have to remove the labels, and the label order is important and has to be captured and restored after the imaging has taken place. The other thing is pinned insects are widely variable in size and shape, and often the orientation is specific to the kind of insect that you are digitizing. And so sometimes you have to change your staging as well as change the level of the camera based on what you happen to be imaging. Insect collections are so large that traditional manual data entry really isn't feasible for most of these collections. And for natural history, with close to 35 million specimens, at 100 specimens per person per day, it would take about 1,346 years working 5 days a week. Even if you had a large team of 20 people, the best you can do is actually cut that down to about 67 years. So you have to look at other ways of digitizing in large volumes rapidly. So today, Jessica and I are going to be talking about our bee digitization project. And I'm going to mainly focus on the physical aspects of the workflow, and then Jessica's going to take over and talk about the imaging and the virtual and data workflows that happened afterwards. So with the physical, it takes a lot of planning, 2 to 3 months in advance, just to actually figure out how you're going to move the specimens, how you're going to stage the specimens, then 1 to 2 months to actually do the imaging itself. And then the actual longest part is afterwards, and you'll hear more about that later in the presentation. For the 2019-2020 team, it really was a team. It took a large group of more than 20 people by the time it was all said and done, but the main team was about 12 people and had a variety of folks cooperating on both the project management side, logistics, and then the imaging and data management afterwards. So for physical, we're talking about we have to move the specimens because the imaging suite wasn't in entomology. We have to talk about disassembly and staging. Remember, we got to get those pins off and put in the right order, taking the pictures, putting it back together, and then getting the specimens back to entomology. So in this case, the bee collection is housed on the 5th floor of the East Court of the Natural History Building, but the imaging suite was on the ground floor of the East Wing, meaning that we had to move it down 5 floors and across into a different part of the building. So it took 2 elevators to get them there, and a lot of walking just to figure out how to do this in a way that would reduce the risk to the specimens themselves. We had 2 13-drawer cabinets that we mounted on 1,500-pound capacity dollies with air-filled tires to move it, with 1 cabinet designated for specimens to be imaged and 1 for those that had already been imaged and were ready to go back. The imaging suite itself was actually shared between the entomology imaging project and the paleobiology imaging project that was happening simultaneously, and was kind of arranged in a horseshoe represented here on the left side of the diagram. So the imaging suite, at least as far as the entomology side, had 3 basic stages. We had the disassembly and staging area, the imaging, and the reassembling and rehousing half. To do this, we had to build special modular tabletops just in order to keep the unit trays that we had the stages built into from falling off of the table, and to make it so that we could do it in an assembly line fashion. So as we were doing this, we had to take a picture of the drawer before, just so we'd have a reference of how the bees were arranged before we moved them. The specimens had to be removed, each bee placed in a staging tray, Labels removed and placed in order on an upper staging surface. A barcode of one of our USNM int barcodes was added to each specimen. Then the bee was pinned in the appropriate location or orientation, and then the assembly line work can begin. So this is what the staging process kind of looks like, taking a bee out of a tray, staging them all with the labels. It was important for us to also track what tray we took things out of so that we could make sure that things not only got back, but got back in the exact same way, in the exact same place in the trays after we were done. Of course, digitizing entomological collections comes up with lots of unexpected issues. One of those is sometimes you have alternate pinning where someone pinned it upside down, or they pin multiple specimens on the same pin, or even in some cases, you have other taxa included on the pin that aren't part of the digitization project. Other things, sometimes specimens have been dissected. You have things like slides and genitalia vials that you also have to keep track of because they go with the specimen. And it's important not to ever allow those to be disassociated from the specimens because you can never put them back with absolute certainty that you've got them paired correctly. There's also the problem of damaged specimens. Sometimes they're damaged before they arrive. That's just natural, especially in older specimens where you get things like this green filigree that you see on the upper image. And sometimes damaging happens in the process of staging. That is a very natural process, but we also have to make sure that we have the ability to repair it and put the labels, the specimen, back together and back into the collection after we've repaired it. The reassembly line looks very much like the disassembly line. You're basically just taking stuff out of the stages, you're putting the labels back on in the same order that they took off, and then returning them to the original unit tray from whence they came. The final step, of course, is now that we've got them imaged, it's time to get them back up to entomology. And so this is them being prepared to go back and go into our freezer as part of our IPM process. Then we move on to the next stage. So at this point, I'm going to turn it over to Jessica, who's going to talk about the imaging and virtual workflows that followed after the physical aspects.
Thanks, Floyd. I'm going to briefly discuss the imaging and the virtual workflows. And I just want to stress how fortunate we were to be able to work with DPO for this portion of the project, since they helped create the framework for our workflows, our scripting, and our automation. So first, here are some different views of PNA and per workstation so that you can see how we had the project set up. There are 4 main parts to the imaging workflow. The item-driven image fidelity analysis is a chance for the department to work with DPO and for us to tell them what we need out of these images to make them scientifically valuable. Since we're only taking a single image, both the specimen and the labels needed to be in focus and on the same plane. It was decided that these images would be captured at 800 ppi with a 12 to 13 millimeter field of depth. In the image to the right, you can really see some of the details that we were able to capture in a seemingly simple image. During the IDIF validation, a test station was created. The target, pictured in the middle, was created to confirm the proper setup. During the image processing, single images were captured, cropped, and processed. USNM int barcode served as the file name for each image, and image sets were grouped by day containing both raw and TIFF files. The final step of movement and placement was already covered in Floyd's physical workflow, but our photographers worked closely with staff to ensure that movement flowed and specimens were taken care of. Many parts of the imaging workflow, especially in regards to data processing, are intrinsically linked to the virtual workflow. So here I just want to give you an overview of the many pathways involved in the virtual workflow. This is very specific to our data management systems, but it can be tailored to fit any system. Images and the associated metadata are moved from the vendor to the DAMs using a hot folder configuration. Then those assets are used to create specimen level records in our collection information system known as EMU. These records are pushed online through the collection search, which ultimately lead to data aggregators such as GBIF receiving our data through an IPT. After that initial data push, images are sent for transcription. Labels are fully transcribed, and that data is appended back into the public records. The entire goal of this process is to publish not only the images that we took, but the data that's on the labels. So to make this process more efficient, we automated as many aspects as possible. During pre-curation, all taxonomic names were assigned a virtual barcode. And at the time of imaging, this barcode was used to associate the species name to the image. The images were all renamed to the unique USNM barcode by using an automation tool. And then required metadata was stored either directly within the image or in a text file. The creation of these individual catalog records and their linked multimedia records in EMU was also scripted. These two newly created records are what we internally refer to as skeletal records because they contain only basic information. One of the best parts about this project is the quick turnaround time. So we go from an insect unknown in the collection to a catalog level record and a published image. Even though at this point the fully transcribed label data isn't available, these specimens are still searchable, and now they can be accessed without a trip to the museum and without a loan request. So I just kind of want to show you what our descriptive records look like in EMU. As you can see here in a catalog record, we have the taxonomy and the barcode, and there's missing information in the bottom portion. Next, we have the multimedia record, which has basic information such as the creator, and other information such as our rights is still missing. Now we reach what is one of the most time-consuming aspects of our digitization efforts. After the photographs were taken, we were able to send all of the images to a transcription service. We created a document to train the transcribers on interpreting entomology labels. So the data was transcribed into our template using the established guidelines. And once it was submitted, SI staff were notified that a data set was available for review. The International Standards for Data Transcription, ISO 2859, was followed when we checked data for accuracy and establishing quality control thresholds. Only a small subset of each data set had to be checked for true errors. And in our case, a true error was only when data was missing or it was done incorrectly. Formatting mistakes or when handwriting couldn't be deciphered, those weren't counted as true errors. So when you have these preset standards, it makes it so much easier to determine if a data set should be accepted or rejected. Once transcription of a data set is marked complete, there's still work that we have to do. So the data has to be reformatted to fit an EMU import, and this would include simple parsing, IRN matching, and adding standard fields. And we also made sure that this collection was georeferenced. Finally, all of that completed data is imported back into the CIS, and we have enhanced original records. So this is an image of our fully transcribed data records. As you can see from the primary catalog, it is now georeferenced, and you can see the collectors. And for the catalog and for the multimedia record, we now have those usage rights stated. Previously, all published images from the Smithsonian or from our collection of the Smithsonian contained the statement rights of usage rights applied, which means that we must grant permission for every photo use. However, the end of this project coincided with the start of the Smithsonian's Open Access Initiative. And under this initiative, all applicable images would enter the public domain. And we use the right statement CC0. So now users can enhance and reuse most images in our collection without restriction under copyright law. This mass digitization project has taught us so many valuable lessons on collection management, data management, and digitization. We have learned the importance of staffing and space, and we are still making improvements on the bottleneck that is post-production data curation. In conclusion, entomology collections offer a huge opportunity to capture large amounts of data rapidly. And even though not all collections lend themselves to this style of digitization, careful selection and project planning can ensure success. This type of project is definitely a group effort. Hiring a dedicated workforce and including an on-site project manager helps to create a strong, positive working environment with high morale. We just want to thank you for all of your time and attention, and we'll be available to answer any questions that you might have. Thank you. Hi, thanks for taking time to watch our program. Unfortunately, Floyd isn't available today, so I'm going to be here to answer your questions. We have a couple in already. So the first question was, do you think these workflows can be used in other museums? And definitely. This whole process is something that we actually did it twice. So this final process is where we were able to perfect our workflow. But the physical aspects of removing the labels, staging, taking one image, that is 100% applicable to any pinned insect collection. And if anyone had questions about some of the automation tools that we use or how the transcription process works, you can reach out to me at any time. I'll be more than happy to answer those individual questions. Another question that we received, would you change something in how the collection is stored to make digitization easier? So that's kind of difficult. For the standard for most insects are that they are dried specimens that are pinned with the labels stored below. We have a few collections, such as the dragonflies, where the insects are preserved flat in envelopes with a larger data label on the back. For that specific collection, we are working on digitization techniques that are similar to the botany conveyor belt. But for the pinned insects, there's just really not a way for us to change that preparation because that's specific to our study. Another question, is it possible to photograph in groups instead of alone to make the process more efficient without having an entire team available to work on the project? So yes and no. I have seen many digitization projects where they image an entire floor. So this was shown in one of the photographs, but our pinned insects are stored in these very large boxes inside of smaller individual unit trays. So you can take an overhead view of the box and even in some cases really zoom in to see pretty good detail on the insects. However, you're not able to capture the data on the label. And that's what we're really going after on these projects when we're doing mass digitization, because we don't just want an image of the insect, we want to capture that data that's on there because that's what's going to be important for researchers to look at and use. We are also working on different types of digitization where the label digitization may be a little bit more automated and more scientific pictures are taken. So we'll just, as we work on that, we'll definitely make that technology available by presentation so that you can see. Do you plan to create 3D digital representatives of the specimens? For example, holotypes. If so, how? So type digitization is one of the things that I am working on with our department. Currently, not all of our types are even online and available. We recently finished imaging the Hymenoptera types through a process that took almost 3 years. And we're constantly working on other imaging. So right now the goal is 2G images. We normally take 3 to 4 images based on the group, a dorsal, a lateral, a shot of the head, just whatever that curator needs to make sure that those images are scientifically valuable. We do have researchers that work on 3D imaging. That is, right now it's more on CT scans, doing smaller features that they need to do research on instead of doing like a 3D scan or an entire model. So that is not a large scale process that we're working on right now. Let's see, another question. Were there cases in which you changed the bees after photographing them? Like if it was upside down on the pen? So no, once a specimen is on that pen, it's very difficult to move. Sometimes these specimens were 75, 100 years old, and they're actually dried to the pen. In rare cases, you can put the insect in a rehydration chamber and try to soften the tissue, but that can cause a lot of issues. So in the case for the bee that was upside down, we just left it, and that can be studied that way if needed. It's just not the traditional or the preferred method for it to be penned and stored. What kind of camera was used and what was the resolution of the photos? I cannot remember the actual camera that was used. Whoever had that question, you can feel free to email me and I can send you all of the specs for the camera and the imaging. It looks like that's all the questions we have for now. We did have one more question coming. What groups are next for photos? So we have confirmed a digitization project for the dragonfly specimens, the dragonflies and damselflies. So we are going to, we already have full data records available online for that group, but we are also going to add images. And we are currently talking about a larger scale pollinator digitization project, which would span pollinators in all groups. So Hymenoptera, flies, beetles, Lepidoptera, but that has not yet been confirmed and is still in the works. Another question that we've received, how has COVID affected this type of project or the museum work in general? So once COVID happened, the museum closed to staff, to limited staff. And actually, even now, we're still working on a limited staff capacity. Contractors who do a lot of our day-to-day imaging were not allowed in the buildings, and also specimens were not allowed to leave the building. So that physical curation and physical imaging was severely halted. We were able to do other things like process data. My job is actually 100% remote. So I work in Louisville, Kentucky. I don't actually work at the museum. I used to, but haven't for the past 5 years. So the data processing, emu imports, image uploading, that can all be done remotely. So during COVID, we took that time to look at our data on how it was being processed and displayed in aggregate sites like GDPR. We tried to clear all of the flags on our data and any data discrepancies, and then also work on georeferencing, because we would prefer for all of our records to be georeferenced. And for the camera type that was used, someone messaged me. So our camera was a phase 1 IQ 180, and they used 100 or 80 megapixels. So that was the camera specs. But back to the question about COVID, we really were lucky that our staff was able to kind of band together and really work on getting some of our data out. I don't have numbers, but we definitely increased our representation of georeferenced localities. We had multiple people that worked on that off and on, and we were able to get a lot of backlog data sets imported into email, which has been nice. And now that the museum is slowly opening up, you're going to see a lot more hands-on work where they will actually be taking images, and soon we will probably be processing more loan requests, because those are also halted with the pandemic. And then this might be our last question. Why are there so many specimens in the collection? So we actually get this question a lot. When you work on insects, part of for some studies, you're looking at population dynamics. So when you go out to the field, you use different methods to collect for each type of species that you're targeting. And so for some of these bees, they would sweep net bees, they would actually look for sites where colonies were present, and then you collect a large amount so that you can look at that over time. Since insects are more populous, it's for our discipline, it makes sense to collect large amounts. You can also, if you collect multiple species or multiple specimens of the same species, you can compare their characteristics and make sure that you're seeing similarities between the species. And also, all of those bees that were collected, the carpenter bees and the bumblebees, those are collections over 100 years. So that's many, many, many years of work by different researchers, different collectors from all over the world. Those aren't just bees from one location. So you really have to look at that over time. And that's also one of the things that makes entomology important when we do these mass digitization projects. It's especially for pollinators or insects that we may think are declining, because with the large numbers that we collect, you can really see that population changing over time. If they were collected in a certain area, if there are more numbers, you would think that it was more prevalent. And then if they're harder to find 20 years later, then we can start asking different questions like, why? Was there habitat loss or climate change that would make that area unable to host those insects? So I know that Floyd and I just want to say thank you again for taking the time to watch our presentation, and thanks to DPO for creating the framework for us to do this.